So section 10.3 is on the ellipse. We're kind of jumping to a different topic here that doesn't directly follow the trigonometry that we've been doing up to this point. So this last couple sections, it's things that you need to see before you get to calculus. Okay, so the shapes we're going to study in the next couple sections, we have one called an ellipse, and then we have one called the hyperbola. These are referred to as conic sections in math. So if we take a cone, and in math here, we look at a line that gets rotated around. So it actually forms two cones, a cone at the top and a cone at the bottom. Conic sections are the shapes we can get from cutting this cone. So for example, some of the easy ones, if we cut a cone across the middle, so think about an ice cream cone, if we just cut it across and we look at what shape we end up with, we would just end up with, the cross section would be a circle. Okay, some of the other conic sections, if we take a cone and we only cut this top part, so think about a cone, and if you were to chop off a side of it and then flip it over, we would end up with a parabola, which we studied in Math 126, Chapter 3. Some of the other conic sections we have, the new ones for us, is if we take a cone and slice it at an angle and look at it, instead of ending up with a circle, we end up with a stretched out circle, or you guys might call this an oval. Technically, we're going to call this an ellipse. And then our last conic section is if we take both of these sections and chop them up, then we end up with two pieces. Our cross section up here would look like this, and our cross section from down here would look like this. This is called a hyperbola. Okay, so these are some conic sections. These are the shapes we get from chopping up a cone. So we're going to study two conic sections. We're going to study the ellipse, and we're going to study the hyperbola in the next section, 10.4. These ones you saw, a circle you saw in Math 126, section 1.4, and a parabola you saw in Math 126, chapter 3. Okay, so we'll start with the ellipse in this section, and then we'll do the hyperbola next. So first up, here's our definition of ellipse. The ellipse is a collection of all points whose sum of distances from 2 points called the foci is constant. Okay, so an ellipse is a collection of all points whose sum of distances from 2 points called the foci. So foci is plural for focus, so one focus, two foci. And technically this can be pronounced foci or foci, either one is correct. And you guys might remember, I vaguely remember doing something in like junior high where you take like 2 thumbtacks and a piece of string between the 2 thumbtacks. And if you take the piece of string and you drag it around, it creates an oval. Okay, so I remember doing that in some previous classes. So we're gonna have 2 ways that an ellipse can be oriented, either horizontally or vertically. And this is gonna change our equation a little bit. So let me show you the 2 possibilities. Either an ellipse can be oriented horizontally, or an ellipse can be oriented vertically. Okay, so what we have is we have the foci inside the ellipse. Looks something about like this. Okay, so our definition is it's the collection of all points whose sum of distances from 2 points is constant. So if we took any point out here and measured the distance from both foci out to this point, it will be the same as the distance from both foci out to this point or out to this point. So the sum of distances is going to be constant. All right, so here comes all of our new terminology for the ellipse. The first one is called the major axis. The major axis is the name we give to the line containing the foci. So when an ellipse is oriented horizontally like this, here's our major axis. We'll say that our major axis is on or parallel to the x-axis when it's oriented horizontally, right? This major axis is either on or parallel to the x-axis. Here where it's oriented vertically, this is our major axis. And in this case, our major axis is either going to be on or parallel to the y-axis. The minor axis is the name we give to the line through the center. That's perpendicular to the major axis. Okay, so in this first picture, here's our minor axis. And here's our minor axis. Okay, I said that the minor axis is a line through the center that's perpendicular to the major axis. We didn't label our center here, but of course, right in the middle of our ellipse, that's referred to as the center. The next term we have is vertices. This should look familiar to you, right? When we studied parabolas, we had vertex was the point at the bottom of the parabola. So vertices, that's plural. So vertices are points of intersection with the major axis. Okay, so on our picture here, these points out here, these are our vertices. The points of intersection with the major axis, these are our vertices. All right, the next thing we have is we're gonna label some distances on these pictures, A, B, and C, and then those variables are gonna come up in our equation, which I'll give you on the next page. Okay, so we're going to always label A as our distance from our center to our vertices. Okay, so A is going to be our distance from our center to our vertices. So on our picture here, from the center to the vertices, this has length A. Okay, from our center to our vertices, this has length A. And of course, from our center to our other vertice here, this also has length A, this is also length A, but I'm only gonna do one on this picture so that we can put in some other important things. The next distance we're gonna measure is gonna be B. These are gonna be the distance from the center to the points of intersection with the minor axis. I'm going to refer to these when we're doing our graphs as the other important points. There's not a technical term for these, like we had vertices were the points of intersection with the major axis. We don't have a special term for the points of intersection with the minor axis. So to save us some time when we're doing this lecture, instead of every single time writing the points of intersection with the minor axis, I'm just going to say the other important points. I'll call these the other points. So if we look at our picture here, our distance from the center to the points of intersection with the minor axis, this distance is going to be B in our equation. On our other picture here, center to the points of intersection with the minor axis, this distance is going to be labeled B. We have one more distance on this picture. You might have guessed it already. That's going to be our distance from our center to the foci. This distance is the last thing we want to have a variable for. So this we're going to call C. Okay, so C is going to be our distance from the center to the foci. All right, so the next thing I'm going to do once you guys get all this down, I'm going to give you the equation for the ellipse, and we're going to see two different equations. So this one, where our major axis is on or parallel to the x-axis, we'll see one equation for, and then if it's oriented vertically and our major axis is on or parallel to the y-axis, we'll see a different equation for. So I'm going to give you two separate equations, one for oriented horizontally, one for oriented vertically. These A, B's, and C's always mean the same thing. So A is always our distance from the center to our vertices. B is always our distance from the center to the point of intersection with the minor axis. And C is always our distance from the center to the foci. Now, throughout this course, I've given you the proofs of formulas when I thought that they were simple and instructive. I'm going to skip the proof of these equations because I don't think it gives you like this aha. I don't think it makes it like much clearer. However, the proofs are kind of cool. So if you're interested in this, or if you're a math major going on to higher levels, I would encourage you just after class, go online and Google proof of ellipse equation. And there's some really cool videos that show you where this equation comes from. So I'm just going to put this up and give you guys a few minutes to jot this down. Let me start with this one. Ellipse with the major axis parallel to the x-axis. Okay, so our equation for an ellipse with a major axis parallel to the x-axis, so that's oriented horizontally. We have x minus h squared over a squared plus y minus k squared over b squared is equal to 1. A has to be greater than b, which has to be greater than 0. It can't be negative. And we have that c squared is a squared minus b squared. Our center is hk. Our foci are a distance of c away from the center. So you can see we've gone plus or minus c to the left and to the right along the x coordinate. Our vertices are a distance of a away. So you can see we started at our center and gone a to the left and a to the right to get to our vertices. These other points, the other important points, the points of intersection with the minor axis, we want to go up and down a distance of b. So you can see we've added and subtracted b onto the y coordinate here. Okay, so some things you might notice. This looks somewhat similar to our equation of a circle. Right, our equation of a circle is x minus h squared plus y minus k squared is equal to r squared. We assume here, since an ellipse is similar in shape to a circle, these equations are going to look somewhat similar. The other thing you should notice is whenever we have a center of a conic section, we usually label it h comma k. So for our circle that we studied in section 1.4 in math 126, we saw hk as the center. When we did parabolas, our vertex, I believe we labeled with hk. So sometimes you see these same variables over and over again. They're just commonly used. Okay. So again, what you want to notice here, this is really important. That's why I've highlighted it. In order to determine that the ellipse has a major axis parallel to the x-axis, what makes it parallel to the x-axis instead of the y-axis is that this variable a that's under the x is larger than b. Okay, so what determines that this is parallel to the x-axis is that a is under x and A is larger than B. So since the larger variable is under the X, that makes this major axis parallel to the X-axis. Some other things you want to note here, the foci, the vertices, these are on the major axis. And since the major axis is parallel to the X-axis, we'll go plus or minus A and C on the X coordinate. These other points, these points of intersection with the minor axis, that's going to be up and down along the Y coordinate. So you can see we've added and subtracted B on the Y coordinate. Okay, next up, here is our equation for an ellipse with major axis parallel to the Y axis. Now notice the differences here. This looks very similar, except for the A's and B's have traded places. Okay, so here, the A is under the Y. So here A is larger than B. So the larger number is under the Y. This is what determines that the major axis is parallel to the Y axis and not the X axis. Okay, so the larger number, whatever variable that's under, X or Y, that determines where our major axis is. And then the larger number we always label with A, the smaller number gets the B. Okay, so you can see our center here again is HK. The foci and the vertices, now that our major axis is parallel to the Y axis, we're moving up and down on the Y coordinate, C and A. So you can see that plus and minus C and that plus and minus A is on the Y coordinates. Our points of intersection with the minor axis, we want to move a distance of B, and since our minor axis is going to be on or parallel to the X axis, we've added and subtracted B on the X coordinate here. And again, I'm giving this to you without the proof, but if you wanted to see the proof, you definitely could Google video for proof of equation of an ellipse. And it's pretty cool, but it's a little bit advanced to do in our class. But you should be able to understand what's going on and see where this comes from. Okay, so let's go ahead and do some examples using these formulas, and I'll teach you how to graph an ellipse. So first one. Okay, so first one, graph the ellipse. We are given x squared over 49 plus y squared over 9 is equal to 1. The first thing we want to do is determine how this ellipse is oriented. Is it horizontal? Is it vertical? Where is the major axis? Okay, so the first thing we're going to do is determine where our major axis is. The major axis is parallel to, I should say on or parallel to, and we need to determine if this is on or parallel to the x-axis or on or parallel to the y-axis. Okay, so the way we determine where the major axis is we look at these numbers in our denominator. Okay, so we look at these numbers in our denominator, we ask ourselves which one's larger. Obviously the 49, that's larger than the 9. The 49 is under the x, so that means the major axis is on or parallel to the x-axis. Okay, so again, we look at our denominator, we see which number is larger. Here the 49 is larger, that's under the x. So that means that the major axis is on or parallel to the x-axis. All right, the next thing we want to do is start listing out our center, our foci, our vertices, and those other important points on here. Okay, so we'll start with our center. Our equation was given as x minus h squared plus y minus k squared. Here we don't have plus or minus anything. Here we don't have plus or minus anything, and I've given you the easiest example first. The center here is just at the origin 0, 0. The next thing we want to do is list out our foci, our vertices, and those other points of intersection with the minor axis. Okay, in order to come up with our foci or vertices and those other points, we know our vertices are a distance of 7 away from are a distance of A away, which I gave it away at 7. These are a distance of A away. These are a distance of C away. These are a distance of B away. So we need to come up with A, B, and C. Okay, so we need A, B, and C. Okay, what we want to do is look at these numbers that are in our denominator. The larger one, that is going to be A squared. The smaller one is going to be B squared. So we have that A squared is 49, which means that A is 7. And if we go back to our definitions from our first page, this is the distance to the vertices. Okay, next up we have B squared is 9, which means that B is 3. This is our distance to the points of intersection with the minor axis. And again, I'm just calling these other points, so you don't have to write points of intersection with the minor axis because they don't have a special name. The next thing we want to do is find our variable C. Our equation told us that C squared is equal to A squared minus B squared. So C squared is equal to A squared, which is 49, minus B squared, which is 9. So C squared is equal to 40. Our next step would be to take the square root of both sides. So we get C is equal to square root of 40. Because we're measuring distance, we don't need to put plus or minus when we take square root of both sides. The last thing we should do is simplify this. So 40 is 4 times 10. So I'm going to write this as 2 root 10. This is our distance to the foci. Okay, so next up, these foci and the vertices, they are on our major axis. The major axis we figured out was parallel to the x-axis. So to get to our foci and vertices, we're going to add and subtract on our x coordinate. This other point, this point of intersection, was with our minor axis. So we're going to add and subtract on our y coordinate. So here, if you want, you can write yourself x, and this is going to be on our y coordinate. So we're starting at 0, 0. To get to the foci, we're going to go a distance of 2 root 10 on our x coordinate. So that'll put us at negative 2 root 10 comma 0 and positive 2 root 10 comma 0. Okay, so I'm adding and subtracting that number on the x coordinates. To get to our vertices, I'm going to add and subtract 7 on the x coordinate. So that'll put me at negative 7, 0 and at positive 7, 0. The other important points are our points of intersection with our minor axis. So we're going to go a distance of 3 along the y coordinate. So that's going to be up and down. So we'll have 0, negative 3 and 0, positive 3. This is all the information we need to graph this ellipse. Any questions so far? Okay, let's go ahead and graph it. And of course, I did this algebraically first, and then I went to the graph. If you prefer, you can always do your graph first and then come up with these points. Okay, so the first thing we saw is that our center was 0, 0. So if you'd like, you can put a dot there, label it center if that helps you. The next thing we had were our foci were a distance of 2 root 10 to the left and to the right. So on my graph here, I'm going to label negative 2 root 10 and positive 2 root 10. Now, in a class without a calculator, how would you know where to put these on your x-axis? Okay, so if we go back up to this point, we had that C was equal to square root 40, which we got 2 root 10. But realistically, if you needed to know where to put this on your x-axis, what you want to do is ask yourself what perfect squares is this between. So the perfect squares it's between 36 would be 6 squared and 49 is 7 squared. So on your x-axis, since 40 is between 36 and 49, square root of 40 is going to be between 6 and 7. Okay, so that's how I figure out about where to put it on my graph. The vertices are a distance of 7 away. So here's negative 7 and here's positive 7. And if you want, if it's helpful to you, you're welcome to label these points however you want. So if you want to put vertices, foci, vertices, you certainly can do that. The other important points we know from our center, if we go a distance of b in either direction, we get our points of intersection with the minor axis. So we should have these here at 3 and -3. The last thing we want to do is connect these outer points with an elliptical shape. And I will apologize to you guys ahead of time. I am not the best artist here, but I will do my best. You guys get the point. All right, actually that wasn't too bad. Okay, so what we should check, our foci, our vertices, those should all be on the major axis, the center of the foci vertices, those are all along the same line. Again, distance of C, distance of A, distance of B. So if you wanted to, you could have drawn the picture first and come up with these points and then looked at these points and figure out what these coordinates were. But there's our first ellipse. Any questions on this? Any questions? Okay, let's do a couple more. Okay, so next up, let's graph the ellipse. And I'm given the equation x minus 3 squared over 4 plus y plus 2 squared over 36 is equal to 1. All right, the first thing we want to do is determine where our major axis is. So here our major axis is on or parallel to. And let's figure this out. That should be our first step. The major axis is on or parallel to. What do you guys think here? The x-axis or the y-axis? The y-axis, good. Okay, so the way we determine where our major axis is we look at the numbers in the denominator. Whichever number is larger, so here the 36 is larger, the variable that's under, that determines where our major axis is. So the 36 is bigger, 36 is under the y, so that determines that our major axis is on or parallel to the y-axis. Now, why do I write on or parallel to? If the center is 0, then it would be on, and if it's off of 0, then parallel. Okay, so technically on or parallel to the y-axis here. Okay, the next thing we want to do is list out our center, our foci, our vertices, and those other points. Once we have all those things, we put them together on a graph and we'll be done. Okay, in order to come up with any of these points, we're going to need to know A, B, and C. So what we want to do is label these denominators A squared and B squared. The larger one is always going to be A squared. The smaller one is always going to be B squared. Now, if you make a mistake and label them in the wrong order, what's going to happen is when you go to find C, which is A squared minus B squared, if you have them labeled backwards, you're going to end up with a square root of a negative at some point, and that should just clue you in like, oh, I just labeled some things backwards somewhere, go back and check your work. All right. So first thing we'll do is we'll label our center. Okay. So our center here, our equation was x minus h and y minus k. So if it was x minus h, that means that the x coordinate of our center is going to be 3, y minus k, so this would be y minus -2. So the y coordinate of our center is -2. All right. So next we need A, B, and C. So we have that A squared is 36, which means that A is 6. That is our distance to our vertices. We have that B squared is 4. That means B is 2. This is our distance to those points of intersections with minor axis. So those I'll just call other points. We don't have to write that again. The next thing we need to do is find C. So C squared is given by A squared minus B squared. So A squared was 36, B squared is 4. So we get that C squared is 32. Take the square root of both sides. we get C is square root of 32. 32 is 16 times 2, so we get that C is 4 root 2. This is our distance to our foci. So again, if you labeled a squared and b squared backwards, at this point you'd have a square root of a negative, which just would remind you to go back and check your work. All right, so this one, our center is not at the origin, so this one's a little bit more difficult than the previous one. Okay, so what I like to do is remind myself that my major axis is on or parallel to the y-axis, which means that the foci and vertices, we're going to move along the y-coordinate to get to these points. The other points of the other important points are points of intersection with our minor axis. That's going to be our other variable, which is x. Now, if you go to my previous example, those were reversed, right? Because our major axis was parallel to the x-axis, we moved on our x-coordinate to get to our foci vertices. So whatever our major axis is up here, this is parallel to the y-axis, the foci and vertices, we need to move on the y-coordinate. So these should be the same. The minor axis concerns the other variable in the other direction, so that's the x. Okay, so what I like to do here is I want to start at my center, which is 3, -2. And on the y-coordinate, I'm going to add and subtract C to get to the foci. So what I'm going to do is leave a blank spot on the y-coordinate, and I'll do the same thing here. So to get to my foci, I need to add and subtract a distance of C, so that's 4 root 2. So I'm going to subtract 4 root 2 here, and I'm going to add 4 root 2 here. Now, if you can simplify things, you should, but this we can't simplify. So let's do the same thing for the vertices. So I'm going to start at my center, which is 3, -2. I know I need to add and subtract a to my y-coordinate, so let's leave an open space on the y-coordinate. 3, -2, open space. Okay, my vertices are a distance of a away. So what I need to do is I need to subtract a and add a to the y-coordinate. So now let's simplify this. I get 3, -2 minus 6 is -8. And -2 plus 6 is 4. All right, the other points, the points of intersection with the minor axis, I'm going to add and subtract B on the x coordinate. So what I want to do is start with my center, so 3, -2, and I'm going to leave a space on the x coordinate. I need to add and subtract B on the x coordinate. So I'm going to subtract B and add B. So simplifying that, I get 1, -2 and 5, -2. Any questions so far? Okay, so now we have everything we need to graph this. And if you're graphing this by hand, what you want to pay attention to is how far out you need to go on your x and your y axes, how far out you need to label this. When you're doing your homework, you'll have an electronic graphing tool, but of course I would always encourage you to try and draw these by hand. So our vertices here, our y coordinates, we need to make sure we get y on our axes from -8 up to +4. And then x goes from 1 to 5, so that's what I need to make sure I include here. All right, the first thing we'll do is plot in our center. So our center was 3, -2. So here's our center, 3, -2. Our major axis is the line that goes through our center, and here it was parallel to the y-axis. So if you want to, you can put in a dashed line This is our major axis. I would say it's not totally necessary to put that in there. Okay, the next thing we did is along our major axis, we went up and down a distance of A and C to get to those vertices and those foci. So let's plot those in. So A was our distance to our vertices, so we went up and down 6 to get to the vertices. So here's up 6, here is down 6. Those should be our vertices. Then we went up and down a distance of C, which was 4 root 2 to get to the foci. So again, what you want to think about is 4 root 2, that was square root of 32. So square root of 32 is between square root of 25 and square root of 36. So that's between 5 and 6. So we want to go up and down something between 5 and 6. So that's going to be right around here and right around here. Those are our foci. Our minor axis is the line that's perpendicular to the major axis and goes through the center. And to get to those other important points, we went to the left 2 and to the right 2, so along our minor axis. And these should match up with all of these points up here, right? 1, -2, and 5, -2, those match up. The last thing we want to do is connect these outer points with our ellipse. And voila, beautiful ellipse. Any questions on this? Okay, so again, you're welcome to do this in either order. What I did was come up with the ordered pairs first and then graph it. But if you're a visual person and it's easier for you, of course, you can draw this first and then count out and then look at this point. Okay, this is the point 5, -2. So that has to be one of my points of intersection with the minor axis. So if you want to do in the reverse order, that's totally fine as well. Any questions on this one? All right, let's do one more. We are asked to graph the ellipse, and we are given x squared minus 2x plus 4y squared plus 8y squared, or 8y plus 1 is equal to 0. Okay, so graph the ellipse. We have x squared minus 2x plus 4y squared plus 8y plus 1 is equal to 0. This is in what's called general form. Anytime we have an equation where we have 0 on one side and then on the other side we have all of our terms multiplied out like this, this is called general form. So what we need to do is we need to put this in standard form. So our standard form was that x minus h squared over either a squared or b squared plus y minus k squared over a squared or b squared is equal to 1. Okay, so we need to put this into the standard form for the ellipse. So we notice that our standard form, if we look back at our equations, our standard form was x minus h squared and y minus k squared. That's in factored form. So what we need to do is factor this. So I'm going to factor this by completing the square. Okay, so factoring by completing the square is something that you should have learned in your Math 096 class. I'll go over this with you in this section, and I'll do another example in section 10.4 of factoring by completing the square. So you'll see me do some review of this, but please realize if you need more help factoring by completing the square, go back to your 096 notes or Google how to complete the square. So completing the square, my goal is to get these x terms in x minus h squared form. So what I do is I start by writing my x terms, and to complete the square, I put plus a blank here. In order to complete the square, what I'm going to do is I take this middle number, and my process is always the same. I'm always going to divide by 2, and square it. Okay, so my process is always the same. Divide by 2 and square. So I take this middle term, this b term, and I drop it right in here. So -2 divided by 2 and squared. -2 over 2 is -1. -1 squared is +1. So what this tells me is to complete the square, I need to add a 1 here. Now we're going to work on our y terms, but this is an equation, right? So I'm doing this in a couple parts here. Anytime I add 1 or any number to one side of the equation, I need to make sure I also do that to the other side of the equation. So if I'm adding 1 here, I need to make sure I add 1 over here as well. Okay, then our next step is to factor this, and I'm going to fill in the rest of this in just a second. I just want to do this one x part first before we work on the y part. So we're going to have some more stuff filled in here in just a second. Okay, so x squared minus 2x plus 1, this factors as x minus 1 squared. So this factors as x minus 1 squared. There's a couple different ways of seeing this. The first way is to factor this when you're looking for two numbers that multiply to +1 and add up to -2. So those are -1 and -1. The other thing we can see is right here, I wrote out this middle step for a purpose. Whatever we get in this middle step drops right in here. Any questions so far? Okay, now we need to handle these y terms. So let's look at our y terms. I have 4y squared plus 8y, okay? What I want to do is complete the square and factor this as well. This one's different because we have these numbers in front. So the first thing I'm going to do is pull out that 4. Okay, so if I pull out a 4, that gives me y squared plus 2y. And I'm going to put plus a blank here. That's what we need to fill in to complete the square. Now, this plus 1 I have right here, we need to move that to the right side. So I'm going to write that as a -1 over here. Okay, so to complete the square, our process is always the same. We always take the middle number, we divide by 2 and square. Okay, so we always divide by 2 and square. That's always our process. So I take this middle number, that's 2, divide by 2 and square. So 2 divided by 2 is 1, 1 squared is 1. So I need to add a 1 here. Now I can't just arbitrarily add something here to the left side. Whatever I add to the left, I need to make sure to add to the right. Now, how many have I actually added right here? Not just a 1, look at this equation. I've actually added in 4 times 1. So if I've added 4 times 1 to the left side, I need to make sure I add 4 times 1 to the right side as well. Okay, let's write our factorization now. So now I have 4 times, and y squared plus 2y plus 1, this factors as y plus 1 squared. There's a couple different ways you can see that. Either you can ask yourself how to factor this. We're looking for two numbers that multiply to 1 and add up to +2. Those are +1 and +1. Or whatever this number is right here, that drops right into the factorization. Let's check out what we have on the right side. On the right side, I have -1 plus 1, that's 0, plus 4, that is a 4. Any questions so far? All right, we don't quite have this in standard form yet. We have one more step. In standard form of equation of an ellipse, we have a 1 on the right side. So the last step here is to get a 1 over here, and in order to get a 1 over here, we need to divide everything by 4. All of our terms by 4. So we're left with x minus 1 squared over 4. These 4's will cancel. Y plus 1 squared, and I'm going to go ahead and put over 1. We need that placeholder so we can find A, B, and C a little bit easier. And then on the right, we have a 1. Okay, so now we're in standard form. All right, so now we're exactly where we started on the last two problems. We have standard form. We'll figure out where our major axis is. We'll figure out where the center, foci, vertices, and other points are, and then we'll graph it. So first step. So what do you guys think? Our major axis is on or parallel to what? The x-axis or the y-axis? Which one? X, good. Okay, so the way we determine where our major axis is we look at these numbers in the denominator, whichever one is larger, so 4 is larger, that's under the x. That determines that our major axis is on or parallel to the x-axis. Okay, next step, let's write out our center. Our equation for our center was, we had x minus h squared and y minus k squared. So this is going to be h and this is k. The important thing we need to remember here is it's x minus h and y minus k. So we need to be careful of the signs there. So here we have x minus 1, so that means that h is 1. And y plus 1, and our equation was y minus k, so that means our x coordinate here should be negative 1. The next thing we'll do is list out our foci or vertices in those other points, and in order to do that, we need a, b, and c. So a squared, b squared, and c squared. We'll list these out. Okay, so the denominators, the larger one is always going to be a squared. So here a squared is 4, which means a is 2. That's our distance from our center to the vertices. B squared here is 1, which means that b is 1. That's our distance from our center to those points of intersection with the minor axis. We'll call those the other points on our graph. The next one we know, c squared, our equation tells us is a squared minus b squared. So here a squared is 4, b squared is 1, so c squared is 3, which means c is square root of 3. That's our distance to our foci. Next thing we'll do is we'll list out our foci, our vertices, and those other points. All right, so the foci and the vertices, these lie on the major axis. So since the major axis is parallel to the x-axis, what we'll do is make ourselves a note here that we're going to add and subtract on that x coordinate. These other points, points of intersection with the minor axis is parallel to the y-axis. So it's going to be the other variable there. Okay, so what I'm going to do to get to my foci, I'm starting at my center, which is 1, negative 1, and I want to add and subtract a distance of c onto the x coordinate. So the easiest way of doing this is I leave a little space on my x coordinate. So our foci are a distance of root 3 away, so I'm going to subtract root 3 on that x coordinate and add root 3 on that x coordinate. All right, our vertices are a distance of a away. So again, I'm starting with my center and I'm going to add and subtract on the x coordinate. So I'm going to leave a little bit of space here. And I want to add and subtract 2 on the x coordinate. So here's subtracting 2 and here's adding 2. We should simplify this. So 1 minus 2 is negative 1. And 1 plus 2 is 3. To get to those other points, those points of intersection with the minor axis, I'm going to add and subtract b onto my y coordinate. So what I'm doing is starting at the center, 1, negative 1, and I'm going to leave space on my y coordinate here. I need to subtract b and add b on that y coordinate. So I get 1, negative 2, and 1, 0 for those points of intersection with the minor axis. All right, the last thing we need to do here is graph this. And this one, our x coordinates go from negative 1 to 3. And our y coordinates go from -2 up to 0. So that should be pretty easy to graph here. So let's see, our center was at 1, -1. Our major axis is parallel to the x-axis. So if you'd like, you can put this dashed line through to indicate your major axis. Here's our minor axis. To get to our foci, we went a distance of √3 in both directions. So √3, that's a little bit smaller than √4, which is 2. So we want to go less than 2, a little bit less than 2 in both directions. So here we go. There's our foci. Our vertices were at -1, -1, and at 3, 1. So there are our vertices. And our points of intersection on our minor axis, we went up and down a distance of 1. So here's up 1, down 1, which is 1, -2, and 1, 0. We connect our outer points with our ellipse. And we're done.